Hello everyone, welcome to the next video on numerical on RL, RC and RLC circuit. In this numerical, what is given data? A 230 volt 50 hertz single phase AC supply. So let us start preparing the diagram side by side. In this case, what is given? A 230 volt 50 hertz single phase AC supply. That is 230 volt 50 hertz. So this 230 volt is RMS value is connected across the series combination of resistance 10 ohm. So here it is connected across series combination of resistance 10 ohm, that is R is equal to 10, and inductance of 20 millihenry. So here inductance of 20 millihenry. So L value is given in terms of millihenry. So this is the given data. And what we have to calculate? We have to calculate the value of XL. Then we have to calculate the value of impedance, that is Z. Okay, so we have to calculate what is the value of Z. Then we have to calculate the current flowing through the circuit. After calculating current, what is the voltage drop across resistance and what is the drop across inductance? That is voltage across each element is to be calculated, and then active power, reactive power and apparent power is to be calculated. So the problem is very simple. Today I'm going to show how to use the calculator for that also. So I have a 230 volt 50 hertz AC supply and inductance is given in terms of 20 millihenry. First I have to calculate the inductive reactance. What is the formula of inductive reactance? XL is equal to 2 pi FL, that is 2 pi 50 into 20 millihenry, that is 20 into 10 to the power minus 3. So let us calculate this on the calculator. 2 shift pi into 50 into 20 10 raised to, so for 10 raised to you press this button only, 10 raised to minus 3. If I press to equal to, it gives me 6.283 ohm. So millihenry is must be converted into ohm before calculating the impedance, so that XL is to be calculated. Sometimes directly impedance is asked. When the impedance is asked, first you determine the value of XL and then calculate the value of impedance. But here I have asked the inductance, inductive reactance first. To step by step we are going. Now in a calculator also, please check that shift mode. If my calculator is in math mode, so if my calculator is in math mode, then what will happen if I type this answer 2 pi shift 2 pi into 50 into 20 into 20 e raised to minus 3 equal to, so see, your answer is coming as a 2 pi. It is not showing in the fraction because your calculator is in math mode. So please change the mode of your calculator, so answer will be in line input output. So press then 2, so it will be line. Now you can calculate 2 pi into 50 into 20 e raised to minus 10 raised to minus 3. So it is coming as 6.283. So I got the value of XL. Now I want to calculate the impedance. So in RL circuit, impedance is always equal to R plus JXL. So resistance is of 10 ohm plus J is the imaginary value, J in 6.283. So this impedance is in rectangular form. So whatever we have calculated this is in rectangular form. Now I want to convert this quantity into polar form. So how I can convert this quantity into polar form on the calculator? For that, go in the mode. See, you can see here complex mode. So press the button of 2. Now it is complex in degree mode. You can observe here complex and degree mode. Now I want to convert 10 plus 6.283. Instead of J, you have to write down the I. So I is E on ENG button. It is activated only when your calculator is in complex mode. So press the button of I. Generally we write down the J initially, but I is later in the complex number. So complete the bracket. Now I want to convert this quantity into polar form. So you press the button of shift 2. So you can here observe first is the argument, second is the conjugate, third is r at an angle of theta, and fourth is the a plus bi. So third is your polar form, fourth is your rectangular form. So I want the polar form, so I will press the button of 3. So at the end r theta will appear. Press the button of equal to. See, if your calculator is in degree mode, angle is in degree. If the calculator is in radian mode, angle is in radian mode. So what answer I am getting here? I am getting 11.899. So I will approximate it as 11.81 at an angle of 32.14 degree ohm. So I got this impedance. Now I want to calculate the current through the circuit. So how I can calculate the current? For the current, the formula is very simple. If I want to calculate the I is equal to V upon Z. V upon Z. So voltage is taken as the reference. It is RMS value. So it is 230 at an angle of 0 divided by 11.81 at an angle of 32.14. So this can be performed on the calculator directly. I will show you how to perform on the calculator. For a numerator value, you can put in the bracket. So I want 230 shift at an angle of 0 bracket complete divided by in second bracket 11.81 shift at an angle of 32.14. Okay, complete this. I want the answer in the polar form. So press shift CMPLX. I want the answer in polar form. So again shift complex and R theta. So my current is 19.48 at an angle of minus 32.14 degree. So this much ampere is my current. Now I want to calculate the voltage across each element. Means I want to calculate the voltage across resistors and voltage across inductors. So first we'll calculate the VR. So to calculate the VR, it is I into R according to Ohm's law. So the current, only take the magnitude of current, 10.48 into value of the resistance is 10. So here you will get the voltage is 194.8 volt. Next, I want to calculate the value of VL. VL is equal to I into XL. So current is 19.48 into what is the value of the inductive reactance? It is 6.283 equal to, so 19.48 into 6.283. Press the button of equal to. I'm getting this voltage 122.39 volt. So likewise, you can calculate the voltage across each element. Now let us see how we can proceed further. I want to calculate the active, reactive and apparent power in the circuit. So active power, reactive power and apparent power in the circuit. So active power is denoted by the letter P. The P is given by VI cos phi, or another formula is there. You can calculate using the formula I square R. So here, what is the value of phi? So phi is nothing but angle of voltage minus angle of current. So what is the angle of voltage here? Angle of voltage is 0 and angle of current is minus. We have calculated that and current. So current angle is how much? 32.14. That is 32.14. So my phi value is 32.14 degree. So we'll put this into this. What is the voltage? Voltage is 230 into current is 19.48 into cos of 32.14. So let us calculate this on the calculator. Voltage is 230 into 19.48 into cos of 32.14. Press the button of equal to. So I'm getting this power as 3793 watt. Or you can use this I square R formula. I square R means 19.48 square into 10 ohm. So 19 6.48 square into 10 ohm. So approximately you will get the same power 3794. So approximately the power is same. So using the both formula we can calculate. So this is which power? This is the active power. Now let us calculate. Okay, so this is in watt. Let us calculate the reactive power. So to calculate the reactive power, so we need Q. So Q is given by VI sine phi. Instead of cos phi, here you can use sine phi. So what is the formula for this? Another formula for this is what? I square into XL. So I square into XL, or use the VI cos phi, is 230 into 19.48 into sine of 32.14. That is whatever the angle we have calculated, the phi angle 32.14 here. Okay, so that angle is taken. Now let us calculate it. 230 into 19.48 into sine of 32.14. Sorry, 32.14, bracket complete, equal to, so I'm getting 2383. The angle of, sorry, the magnitude, or you can say, if I want to calculate Q, what is the unit of the Q? The unit of the Q is Holt Ampere Reactive, VAR, V capital, A capital, R suffix. You can calculate using this another formula, 9.48 square into XL value is 6.283. Okay, so by using this formula also I can calculate it. So 19.48 square into 6.283. Press the button of equal to, you are getting the same value, approximately 1 or 2 VAR value difference is there. So this is valid. 10% answer, 5% answer deviation is allowed. Now let us calculate the apparent power. Apparent power formula is very easy. It is only V into I. So V is 230, I is 19.48. 230 into 19.48, press the button of equal to, I am getting 4480. What is the unit? VA. Why VA? Because voltage is in volt and current is in ampere, so this unit is VA. Or alternatively, S can be calculated as I square into Z. So I square, I value is 19.48 into, what is the value of the Z given in the problem? Okay, Z we have calculated in the problem 11.81. So 11.81. So let us calculate 19.48 square into 11.81. Approximately we will get the same value, 4481 VA. There is one more another formula to calculate the value of S. So S can be calculated as under root P square plus Q square. That is under root 3793 square plus 2383 square. So you can calculate this on the calculator. Root in bracket 3793 square plus 2383 square, bracket complete, then press the button of equal to, you are getting the same approximate value, 4479 VA. So by this way you can tally your answer also, whether your answer is correct or not. Hope you understand this video. If you like this video and if you want more video on this, you can you can subscribe my channel, or you can subscribe my channel, and please give the comment in the comment box which problems you want to solve. Thank you.